Hi all, and welcome to the first lesson of this week. We're going to talk more about exponents, which we started last week, but now we're also going to be talking about negative exponents, because just like regular numbers, we can also have negative exponents here. And so we're going to introduce our last rule of exponents for this lesson, where we have, if I have x to a negative exponent like this. Now, what's interesting about negative exponents is that they will turn into fractions. What do I mean by that? Well, what you can imagine is you can take the line of the negative here, and if you draw that out, it becomes a line of a fraction. This is the way that I recommend students remember this. So we've got our x term, or the base of the exponents, in the denominator with a positive exponent now. And then when we don't have anything left in a fraction, we put a 1. And so this is how we turn things into this new fraction. Now, all the other rules still apply to negative exponents. So for example, if I'm looking at number 1a here, evaluate 10 to the 7th times 10 to the negative 4. These are being multiplied and they have the same base. So that means we're going to use our rule from last week and add them. So this becomes 10 to the 7th plus negative 4, which we can simplify as 10 to the 7th minus 4. Write it like that. And that's 10 to the 3rd. If I wanted to evaluate farther, I could. 10 to the 3rd is 10 times 10 times 10, which is 1,000. So the rules still apply with negatives. Now, it becomes a little bit trickier here when we have something like 6 to the 8 times 6 to the negative 10. Again, they have the same base, so we're going to add the exponents. Notice that, again, the base is staying the same. So 6. This becomes 6 to the 8 minus 10, which is 6 to the negative 2. Now, if I'm asking to evaluate, we're going to take that line of the negative fraction and turn it into there. And then we end up with 6 squared. Notice again, this exponent is positive in the denominator. The numerator is empty, which means we fill it in with a 1, giving us the final answer, 1 over 6 squared, which is 36. So that's how you would use negative exponents with multiplication problems. Let's look at some other operations. Here, we have a division problem. We have 2 to the 3rd over 2 to the 5th. We can use our same rule because it has the same base to say that this is the same as 2 to the 3 minus 5, which is 2 to the negative 2. And we can draw that back into a fraction. And we end up with 1 over 2 squared, which is 1/4. Now, if you're not sure why this works, one thing you can also do is you can expand this out. And this is what I always recommend that if you're stuck. So 2 to the 3rd is 2 times 2 times 2. And 2 to the 5th is 2 times 2 times 2 times 2 times 2. Now, since it's a fraction, we can simplify. And you'll notice here we ended up at the same place, which is nothing in the numerator, so a 1, and then 2 squared in the denominator. So again, if you're stuck, I always recommend that you expand those exponents out, which can be really helpful. Now for part D here, we need to remember our order of operations, which tells us that we should do our parentheses first. So 7 minus 5 is 2 squared over 4 minus 6, which is negative 2 to the 3rd. Since these don't have the same base, we can't simplify right now, but we can use our exponents. 4, and then this would be negative 2 times negative 2 times negative 2. So we end up with 4 over negative 8, which can be simplified. It's a positive over a negative, which is going to end up with a negative, and then 4 over 8 simplifies to 1/2. Now let's look with some variables. Again, the same rules apply as before. Here we have the same base multiplied, so we get x to the 6th plus negative 3, which simplifies to x to the 3rd. Here we have terms that have both a number and a variable, which I like to do is use the commutative property to reorder, because all of these are just connected with multiplication. So when I use the commutative property to reorder it, I'm going to put the numbers next to each other, and I'm going to put the x terms next to each other. Then what we can do is combine those like terms, 3 times 4, which is 12, and these terms, which have the same base, so we can add their exponents. So you get 12 x to the 5 plus negative 4, which is 5 minus 4, which is 1. You can leave it like this, but we don't need to actually write that 1, because x to the first is the same as just x. Now here's our last one here. When we have w to the 4th over w to the negative 10th, we can start by just simplifying by subtracting the exponents. 4 minus 10. 4 minus 10 is negative 6. Now what you will often see in the instructions, and which I will also write in the instructions, is to answer with positive exponents. And what that means is that turn every negative exponent into a fraction with a positive exponent. You'll notice negative here, positive in the fraction, for your final answer. It's like saying simplify your fractions for your final answer. It's not that this is not the same, but when we write our final answers, we want it to be with positive exponents. So your final answer would be 1 over w to the 6th. I know this is a bit of a longer lesson, so please leave me any comments or questions that you have, or you can set up a meeting and I will get back to you as soon as I can. Have a great day.